Okay, looking at number 19, here I have y equals 1/3 x minus 59. The second equation is x minus 3y minus 15 equals 0. We look at the first equation where the y is isolated, and we see that y is equal to 1/3 x minus 59. We're going to use that fact and do a substitution in for y in the second equation. So our second equation is now going to read x minus 3, then the quantity 1/3 x minus 59, and then minus 15 equals 0. Using distributive property, I have x minus negative 3 times 1/3 is 1. So it's negative 1x and then I have negative 3 times negative 59 is negative 177, or positive 177, minus 15 equals 0. Okay, at this point we have issues, because now I have 1x minus 1x is 0x. So I have 0x plus 177 minus 15 equals 0. So I have 177 minus 15 equals 0. And I have here, if I add 15 to both sides, I get 177 equals 15. Well, I know this is not true. So what does that tell you? What that tells you is that this is an inconsistent system, which further tells me that these lines are probably parallel. So let's look at this a little further. We know in the first equation that my slope is 1/3 x. If I were to go ahead and rewrite the second equation, let's write the second equation again. Let's write the second equation. I have x minus 3y minus 15 equals 0. So if I add 15 to both sides, now I have 1x minus 3y equals 15. Okay, this is in the form ax plus by equals c. From this I know my slope is negative a over b. So here I have negative 1 over negative 3, which is 1/3. Oh, guess what? That's the slope of my first equation. Okay, and if I look at my y-intercept, which is c over b, I know that that's 15 over negative 3, 15 over negative 3, which is negative 5. So I know my y-intercepts are different, therefore the lines, the slopes are the same. And the y-intercepts are different. Therefore, lines are parallel. And no solution. Slopes are the same and the y-intercepts are different. Therefore, lines are parallel and no solution.